All right, let's have a look at a Facebook Hacker Cup problem called wine testing. So, as you may or may not know, Hacker Cup or Meta Hacker Cup is coming up this week. So I thought I'd reminisce on an old problem that I was super proud to solve at the time. I guess I was pretty new to this stuff and managed to use some recursion and memorization and things like that, which were pretty new to me. So I was happy to solve this problem. So let's see if we can solve it with Rust. So in the problem, we're given up to 100 glasses of wine and we test them all, and then we get blindfolded and we test them all again, and we have to label each glass with one of the wines. And we're asked, like, how many ways are there of getting at least a certain number of our guesses correct. So let's say the problem is you've got 10 glasses of wine and you need to get at least 3 of your guesses correct. Then what is the answer? How would we work that out? So let's just say there's 10. So 1, 2, 3, 4, 5, 7, 8, 9, and 10. So if we got, let's just say we need at least 3 correct. Let's just say we got the first 3 correct. And then this one we get wrong. So let's just say we go 5, 6, 7, 8, 9, 10. It's actually not that easy to find 7 glasses of wine that are all incorrect just by random. There's a chance that you might get one correct by mistake, but you know what. So you can see these ones are correct and these ones are all incorrect. Yeah, so but it's not just that we want 3 correct and 7 incorrect. We need at least 3 correct. So we need to think about solving for when 4 are correct, 5 are correct, and so on. So let's say we're trying to solve for 10, 3. So that's saying 10 glasses of wine and we need at least 3 correct. So we're breaking the problem down and considering just 3 glasses at a time, then 4 glasses, then 5 glasses, and so on, and we're going to add all those up. So let's just consider that we just want 3 correct. Then how many ways are there to choose these 3? Well, that's 10, choose 3. 10, C3. And then we need to multiply that by how many ways there are of choosing 7 incorrectly. And that's kind of the tricky part. And I mean, the point of dividing, I wanted to divide this into subproblems because usually each of those subproblems will be easier. It's pretty rare that a subproblem will be more complicated than the original problem. Or maybe it's just depends if you have a knack for how to divide problems. But often what will happen is when you divide the problem, you find out one of the subproblems is actually the same as the original problem, which means you haven't actually solved anything. You haven't solved the problem, but that subproblem's smaller. And so then you can divide that subproblem again, and you keep dividing until you get down to a base case, which you can just solve manually. And so that turns out to be the case. But I'll let you have a quick think about it. How would you find out the number of ways of getting 7 wine glasses incorrect? And we can consider that 3 of them are already matched up correctly. So we've got 7 glasses and we need to get 7 labels. So we need 7 labels that are all incorrect. Well, I guess if the way to think about it is similar to what you do in probability theory, where sometimes you can't work out the chance of something happening, but you can work out the chance of it not happening. It might be easier, so you go 1.0 minus the chance of it not happening equals the chance of it happening. And in this case, we kind of want to go, and this is, I guess this is what I was proud with, was coming up with this insight, was if we just approximate it as 7 factorial, because there's 7 factorial different ways of arranging all of those 7 wine glasses. But then we need to subtract all of those possibilities that had at least one correct. And that turns out to just to be the same thing that we were looking for in the original problem. So it would be minus solve. So we need at least one correct, which is what we don't want. So we want 7, 1. So that's saying this is basically all 7 factorial possibilities minus all of the possibilities that have at least one correct. And that means this is all the ways of having everything incorrect multiplied by the ways of getting 3 incorrect. And as I mentioned before, we need to do that for 3. We need to also do it for 4. So this would be choosing 4, which means this would be a 6. And this would be a 6. And so on. And then I guess it'll get a bit more tricky towards the base case, where this goes to like 9 and 10. And this goes to 1 and 0. So this goes to, I think it was, this is 1 and 0. And it's not possible to get one incorrect because there's nothing to swap it with to make it incorrect. So this 1 is equal to 0. And if you had to get all 10 incorrect, if you had to get all 10 correct, then there's only one way of doing that. So we can just ignore these in our calculation as 1. So basically we're going to do the sum. So we have a for loop. Correct goes from 3 to 8. So our answer will start off as 1, which will be this bit. And then we'll go answer plus equals and this formula here. So that was choose and I think the variable was G. I'll type this code up. Choose, I'll just say glasses, comma, and this is number in glasses minus correct, factorial, minus, and then this is glasses minus one, I think. And we need to be careful because these numbers are getting quite big and things like that, so we've got to use that modulus. But this is just where it comes down to implementation. So yeah, let's give this a try. So I'll copy this sample input. These are the answers we're looking for. Okay, so I'll just copy this template. That we've done in a previous video. And so the number of glasses of wine and the number that we need to be correct. Make a helper function for this. Okay. So we start off with 1, as we mentioned. Let's return the answer. And for correct, and what was it? It was C to G minus 1. Plus equals we need the modular. We've got to be careful here not to overflow U size. There's like a modular integer you can use, which automatically rotates and based on your modular. Let's make this a global. We need this choose method, and we need this. This could overflow as well. This needs to be mutable. Factorial. Let's see. Factorial G minus correct times. What was this? This was where we regress. And it was G minus correct. We need these methods. Alright, and I know a library for this, which we've used in that previous video where we did the pancakes about 3 or 4 videos back. Yes. I guess we don't want to build this, yeah. We'll build it. Yeah. So I'll make this a global. Maximum was 100. So what this does is it just pre-computes the factorials that we'll need, and also these inverse factorials, which is just the same as dividing by a factorial. And this is our choose method, so n choose k, or whatever you call it. So I guess I'll just pass it in. Is it not possible to get the factorials? No, it works. Okay. Let's keep playing. It's this. Okay. Hope we don't get any rounding errors or overflows. Sometimes you have to be careful, like modulo can be negative, and yeah, this is actually supposed to be subtraction. So like, I guess this could be negative, right? There's no reason this can't be bigger since there's a modular, so I'll just add the mod here. And then I think, yeah, this is always going to be bigger than this, so it's never going to be negative. And so I think that this is always positive, and when we take the modulus of a positive, I think it's always positive. Yeah, I think this looks alright. And we started off at 1, yep. Okay. Guess we can give this a try. Wow, did that actually work? Yeah, looks good. And this is going to be a little bit slow. So, how many test cases are there? It's only 20 test cases, but still, this can be getting called a lot. So we want to add some memorization. So let's make a cache. And I need to mutate this. So mutable reference to our cache. And we need to give this a tab. What do we want? We want usize to usize. So if let sum answer equals cache dot get, see, oops, that's a reference. Okay. So now we need to set it. Oh, it's complaining. This needs to be a reference as well. Okay. Cool. And I guess just for fun, let's try running it on their test data. So how do we submit this? Submit for practice. Download full input. didn't blow up. And it's nice running it in dev mode, I guess, debug mode, because it would have told us if we had any overflows or anything like that. But we can, I think, do release mode. I think we can just go like this. And go to out.text. Cool. And if we want to time that, so it's pretty quick. Cool. So maybe our code's a little bit faster than it needs to be. And what are we looking for? Is this our output? Okay. And our source code. Cool, fully correct. So yeah, I thought that was a fun little problem. And you can see my submission, 2011. Anyway, yeah, maybe a problem that kind of suits Python because it's got such large integers, you're less likely to get an overflow by mistake. But yeah, so thanks for watching. Feel free to subscribe. I'll post another video on a really tough Hacker Cup problem from a couple of years ago where I found a good OM solution for that. But yeah, hopefully see some of you at a Hacker Cup.